Welcome to Cloud Uni. The lesson today is an introduction to big data and Hadoop, and what is the role of Hadoop in big data. Every day, we hear about big data, but what big data actually means. Today, we will look at the concept of big data and why big data has arrived. This presentation is brought to you by Cloud Uni, a learning platform of data science for busy people. Before big data arrived, companies have large databases to keep their data such as sales, products data, customer and employee profiles, etc. There are popular enterprise databases SQL Server, Oracle, Teradata, MySQL, which helps the companies look after well their data, maintains the accuracy, integrity, consistency and completeness of data. Social media sites like Facebook, Google, and LinkedIn. All these sites generate huge amount of data on a day-to-day basis, as they have billions of users worldwide. E-commerce sites like Amazon, eBay, Alibaba generate huge amount of logs from which users' buying trends can be traced. All the weather stations and satellites give very huge data which are stored and manipulated to forecast weather. Telecom companies like Teltra, Vodafone, OneTel, and Optus study the user trends and accordingly publish their plans, and for this they store the data of its million users. Share markets and stock exchanges across the world generate huge amount of data through its daily transactions. With such large data sets from social media, e-commerce site, weather stations, telecommunication and share markets arrives every day, the traditional database systems are unable to process them. The widely quoted 2011 Big Data study by McKinsey highlighted that definitional challenge, defining big data as say datasets whose size is beyond the ability of typical database software tools to capture, store, manage, and analyze. Around 2005, Hadoop, an open-source framework created specifically to store and analyze big data sets, was developed that same year. NoSQL also began to gain popularity during this time. The development of open-source frameworks, such as Hadoop, Hive, Cassandra, and more recently, Spark was essential for the growth of big data because they make big data easier to work with and cheaper to store. In the years since then, the volume of big data has skyrocketed. While big data has come far, its usefulness is only just beginning. Cloud computing has expanded big data possibilities even further. The cloud offers truly elastic scalability, where developers can simply spin up ad hoc clusters to test a subset of data. What are the main technologies and tools to help manage big data? First, Apache Hadoop is a framework that allows parallel data processing and distributed data storage. Next, Apache Spark. It is a general-purpose distributed data processing framework. Apache Kafka is another brilliant big data management tool. Apache Kafka is a community-distributed event streaming platform capable of handling trillions of events a day. Initially conceived as a messaging queue, Kafka is based on an abstraction of a distributed commit log. Since being created and open-sourced by LinkedIn in 2011, Kafka has quickly evolved from messaging queue to a full-fledged event streaming platform. What's next? Apache Cassandra is a distributed NoSQL database management system. Apache Cassandra is a free and open-source, distributed, wide-column store, database management system designed to handle large amounts of data across many commodity servers, providing high availability with no single point of failure. Before we go further into getting to know technologies that can help manage big data, we should first get familiar with a very popular programming paradigm called Reduce. What it does is, it allows performing computations on huge data sets on multiple systems in a parallel fashion. Big data analytics helps organizations harness their data and use it to identify new opportunities. That in turn leads to smarter business moves, more efficient operations, higher profits and happier customers. They got value in the following ways: cost reduction. Big data technologies such as Hadoop and cloud-based analytics bring significant cost advantages when it comes to storing large amounts of data, plus they can identify more efficient ways of doing business. Faster, better decision-making. With the speed of Hadoop and in-memory analytics, combined with the ability to analyze new sources of data, businesses are able to analyze information immediately and make decisions based on what they've learned. New products and services. With the ability to gauge customer needs and satisfaction through analytics comes the power to give customers what they want. It is pointed out that with big data analytics, more companies are creating new products to meet customers' needs. There are some terms associated with big data that actually help make things even clearer about big data. These are essentially called the characteristics of big data and are termed as volume, velocity, and variety, giving rise to the popular name 3 volts of big data, which I am sure we must have heard before. But, if it feels like new to you, do not worry. We are going to discuss them in detail here. As people are understanding more and more about the ever-evolving technological term, big data, it shouldn't come as a shock if more characteristics are added to the list of the 3 volts. These are called veracity and value. Here are 5 V characteristics of big data volume. Organizations have to constantly scale their storage solutions since big data clearly requires large amount of space to be stored. Volume. Since big data is being generated every second, organizations need to respond in real time to deal with it. Variety. Big data comes in variety of forms. It could be structured or unstructured, or even in different formats such as text format, videos, images, and more. Veracity. Big data, as large as it is, can contain wrong data too. Uncertainty of data is something organizations have to consider while dealing with big data. Value. Just collecting big data and storing it is of no consequence unless the data is analyzed and a useful output is produced. It must be pretty clear by now that while talking about big data, one can't ignore the fact that there are some obvious challenges associated with it. So moving forward in this blog, let's address some of those challenges. Quick data growth. Data growing at such a quick rate is making it a challenge to find insights from it. There is more and more data generated every second, from which the data that is actually relevant and useful has to be picked up for further analysis. Storage. Such large amount of data is difficult to store and manage by organizations without appropriate tools and technologies. Syncing across data sources. This implies that when organizations import data from different sources, the data from one source might not be up to date as compared to the data from another source. Security. Huge amount of data in organizations can easily become a target for advanced persistent threats, so here lies another challenge for organizations to keep their data secure by proper authentication, data encryption, etc. Unreliable data. We can't deny the fact that big data can't be 100% accurate. It might contain redundant or incomplete data, along with contradictions. Miscellaneous challenges. These are some other challenges that come forward while dealing with big data, like the integration of data, skill and talent availability, solution expenses, and processing a large amount of data in time and with accuracy so that the data is available for data consumers whenever they need it. Knowledge about big data is one of the most important skills, required for some of the hottest job profiles, which are in high demand right now, and the demand in these profiles won't be dropping down any time sooner, because, honestly, the accumulation of data is only going to increase, over time, increasing the number of talents required in this field, thus opening up multiple doors of opportunities for us. Some of the hot job profiles are given below. First new role in big data is data analyst. Data analysts analyze and interpret data, visualize it, and build reports to help make better business decisions. Another new role is data scientist. He mines data by assessing data sources and use algorithms and machine learning techniques. Data architect is a role in data management field long time ago, but he become more important in big data science. He is responsible for big data architecture, design database systems and tools. Database managers control database system performance, perform troubleshooting, and upgrade hardware and software. Last but not least, big data engineers. These guys design, maintain, and support big data solutions. There are a lot of opportunities if you want to step into big data science. I will talk more about them in next videos. My name is Tony Nguyen. Thanks for watching my YouTube channel. Do not forget to click like button to support me and subscribe my channel to receive notifications of new videos.